All right, welcome back to day 2 video notes of exponential equations, and you've just done a Desmos activity. And in the activity, you were supposed to sort of discover what happens when we change from just a generic basic parent function of the exponential, which is a times b to the x, and we do some transformations or some shifts. So we've seen this h and k before. It helped shift a parabola in the vertex form. So this h and k is just going to move the basic exponential function. And again, the basic exponential function, if b is greater than 1, shoots up like this. And if b is less than 1, it would be shooting down like this. They both would have y-intercepts at 1. Or if a is out front, it would be whatever that a value is. And again, that negative out in front here would just reflect these two over top of the x-axis, which happens to be the asymptote of a times b to the x. But this guy over here is going to change the asymptote. So we're just going to quickly talk about what h and x do in the note sheet from the other day. So h is going to be a right-left shift, just like it has always done because it's right next to the x, and it is a land of opposites, which means that if it is a minus h, it goes to the right, and if it is a plus h, it goes to the left. And k, out there on the end, is our vertical shift. So again, this is horizontal. This would be vertical, which means it's our up-down shift. And this is not land of opposites. It's outside of your function, so it's happening to the output. So a plus k would go up that many units, and a minus k would go down that many units. And important enough for me to come up here and change this, the horizontal asymptote, which is on a generic, this a times b to the x, is just at 0, this up or down is going to shift it. So my horizontal asymptote is actually going to be whatever k is. So y equals k is my horizontal asymptote. That's a good thing to know. Also, just quickly, because it's going to show up, we sort of alluded to growth and decay. Growth and decay is going back to the generic. I'm not going to really worry too much about shifting it right, left, or up or down. Growth in general is when you have a value of b that is greater than 1. And decay is when your b value is between 0 and 1. So you can quickly look at any exponential function and know if it's growth or decay. If this thing's more than 1, it's growth. If it's between 0 and 1, it's decay. So there's nothing hidden there. I will tell you that the growth rate will be written as a percentage. And so if I had an equation like y equals 1.3 to the x, this is bigger than 1, so this would be exponential growth. And how much bigger than 1 is it? It is 0.3, so it would be a 30% growth rate. And in contrast, if I had something like y equals 0.75 to the x, notice that this 0.75 is between 0 and 1. That means this automatically I know is decay. And the decay rate would be 25% rate of decay. Whoops. And we're getting that because in the decay means it's getting less. It's going down like this. So in chemistry and some other classes you've heard of half-life, that's decay. What's happening is it's this b value is 1 minus the rate of decay, because you're taking it away, and this rate would be as a decimal. Where over here, for growth, your b value is going to be 1 plus your rate of growth, because an exponential growth is going up and it's happening very quickly, like the spread of a virus. So this r would be a decimal, and you would add it to 1, and so this is what's being added to 1. Those are pretty easy to identify. This one's a little trickier, because you got to think about what was taken away from 1 to get here. And that would be 0.25, because that's supposed to be a 7 in there. So we don't get those two confused. All right, now we're going to do a couple quick examples and we're going to move on. So if I look at this example, just quickly talking about whether it's growth or decay, this is my b value in here. It's bigger than 1, so this one would be growth for sure. The asymptote is going to be whatever my k value is, which is a +2. So my horizontal asymptote's at +2. So I can kind of start to build this graph a little bit if I wanted to, because I know for sure now it's not going to cross this guy right here. We'll talk about domain and range in a minute. One technique I do for graphing these is to graph the parent function first and then apply my transformations. So the parent function would just be 3 to the x, no transformations at all. So if I make a quick xy table for this one, if I could draw the letter y, it'd be helpful. And we used to use -1, 0, and 1 because they're pretty quick. If I put -1 in there, that makes 3 to the -1, which just flips it. It doesn't make it a negative. If I put a 0 in, it's just 1. There's no a value out in front, so my y-intercept would be 1. And if I put a 1 in there, I get 3. So again, parent function in red would be would start with an asymptote down here. It would have a y-intercept at 1. When I went to 1, it would go up to 3, and it would have a -1, a really small value. So it would look kind of like this, like the sound effects. Now what I'm going to do is I'm going to transform that guy, and my transformations are right here, which is -4, which means I'm going to go to the right 4, and this means I'm going to go up 2. So all of my values are going to change. My x's are all going to have 4 added to them, and my y's all have to have 2 added to them. Now, if there had only been one of these, then I would only have to change one of the x's and y's. So if I add 4 to this, I get 3. If I add 4 to this, I get 4. If I add 4 to this, I get 5. So I just shifted all of these x values to the right 4. These all go up 2. That would be 5. I add 2 to that, I get 3. I add 2 to that, I'm like, whatever, 2 1/3, no problem. So now my new graph is really going to take each of these red dots and I'm going to shift it over 4 and up 2. So the other way you could do it is if you graphed your parent, you could literally count 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. And this is the hard one because he's like a little baby fraction, but he's going to be right there. And your graph is going to zippity-doo-dah. Looks exactly the same, it just got moved to the right and up. Now, I want to talk about domain. Exponential functions, every exponential function, the domain is -infinity to infinity. Does not change. They always go left to right. Whether they're going up or down, it doesn't matter. The range, however, you'll notice that on this case, the range is stopped by your asymptote. So in this case, it's going up. So it starts at my asymptote and it goes up to infinity. So your range is going to be dictated by this guy, which is also your horizontal asymptote, kind of like some of our other functions. All right, we're going to do one more after I erase some of this so we can use this space effectively. Erase, erase, erase. Again, the beauty of this video is you can zoom back and pause if you need to. All right, so I need to bring this guy out because I can't see him. He's behind me. Nobody wants that. All right, here we go. Back at it. So if I start with this again, 1/2, if I just talk about growth or decay, 1/2 is between 0 and 1, so this would be decay. It's going to go down. Also, it's a fraction, not a decimal, but that means my decay rate is 50%. I have my parent function. I'm going to erase this because I want full access over here, and I don't want us to see this messy stuff. Mess, 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 mess. All right, back at it. Here we go. So the parent function, so I'm just going to use a p for parent, would be y equals 4 1/2 to the x. So if I were to graph this thing, again in green, that means my horizontal asymptote would have started here. And I would have put in 3 quick points, -1, 0, and 1. And if I put -1 in here, that's a little tricky, so I'm going to write that one out. 4 times 1/2 to the -1 is the same as 4, and 1/2 to -1, that negative just flips it, so that becomes 4 times 2, which is 8. So at -1, I would be way up here at 8. If I put in a 0, that becomes 1 because anything to the 0 is 1, so my output is 4. So my y-intercept would be right here at 4, which is halfway between 0 and 8. And if I put a 1 in here, I'm going to have 4 times a half, because a half to the first is just a half, and half of 4 is 2. So at 1, I would be at halfway between 4 and 0. So you can see that parent function would come down like this. All right, I'm just going to draw it. I'm not going to try to dash it. And it levels off. So what we're going to do is we're going to transform that now. And our transformations are right here, which is left 1, because it's a +1. And this is a down 2. So I'm going to erase some of this, and I'm going to erase my work and just put my numbers in there, and so I can have some room to expand this guy over here. So my numbers were 8, 4, and 2. So my transformation is going to include all my x's moving left 1, which is -1, and all my y's moving down 2, which is y -2. So if I take 1 away from that, I get -2. Take 1 away from that, I get -1. Take 1 away from that, I get 0. And over here, if I take 2 away from that, I get 6. If I take 2 away from that, I get 2. And if I take 2 away from that, I get 0. So that means I would be at 0, 0, -1, 2. -2 is going to be at 6. And so my actual graph is going to go like this. But I do want to point out that my y -2 means that my horizontal asymptote is right here. So my horizontal asymptote is going to be down here. And again, I'm just making sure I did all my math correctly. And it does look like I do. So my new function is going to come down like this and level off right there. So in this case, my asymptote, my horizontal asymptote, is y equals -2, because it's right there. My domain, as we discussed, is -infinity to infinity. It goes forever left to right. And my range, again, this one didn't get flipped. There's no negative out in front. If there had been a negative here, this guy would be upside down. It's not, so it starts at my horizontal asymptote of -2 and goes up forever. So this guy is pretty important. I do want to show you one more thing. I don't have to do it on this one because I accidentally found the y-intercept anyway, but actually I will show you, because if you need to find the y-intercept, which sometimes is very helpful to anchor your point, you do the same thing you always do, which is you plug in a 0 for x. So if I had to find the y-intercept on this, I would plug in 0 for x right up here, which would make 0 plus 1, and 4 times a half is 2, and 2 minus 2 is 0. So I accidentally already found that y-intercept. That's not always going to be the case. So if I move back over here and do a quick erase of all of this, in this one I didn't graph the y-intercept, but if I wanted to, I would put a 0 in here, so I'd have 3 to the -4 plus 2. And this is not going to be a pleasant y-intercept, because 3 to the -4 is 1 over 3 to the 4th plus 2. And 3 to the 4th is 81, so this becomes 2 and 1/81st, which is just above 2, but notice that's my horizontal asymptote, so I'm just above my horizontal asymptote. Very difficult to graph, but it gives you an idea where it is. Sometimes these graph out pretty nice when you put a 0 in there, so that's always a good stabilizing point to do. I've used up all of my 15 minutes on my video, and I apologize. I just got super excited about these exponential functions, as I'm sure you are. So enjoy the rest of class trying to work some of these, and go back to this video, watch, pause. Apologize for the pretty poor handwriting on here, but you know, we're in isolation, so it's what I got. All right, peace out.